Okay, graphing rational functions. Today we're finding asymptotes. This is going to be super important once we get into calculus next year. When noticing your inner critic, ask yourself, how could I be kinder to myself right now? I talk about mental health a lot, mostly because I struggle with mental health, and I think we need to live in a society that normalizes talking about mental health, and I think we're getting to that point, but I think we need some work. So be kind to yourself. My dad always told me you can't love anyone until you love yourself. And that is so true. You can't, and same with being kind. Like, you can't be kind to other people until you're kind to yourself. So speak kindly to yourself. Give yourself the benefit of the doubt that you probably give other people. We are more likely to give other people the benefit of the doubt rather than ourselves. If you're anything like me, I am a huge critic on myself, and on other people, I'm like, oh, they're probably just having a bad day. Well, you need to be that way for yourself also. Okay, let's get into some math. So an asymptote is a line that a curve approaches as it heads towards infinity or negative infinity, either way. And there's 3 different types of asymptotes. We have horizontal asymptotes, we have vertical asymptotes, and we have oblique asymptotes. And then this can go towards positive or negative infinity. And asymptotes are kind of weird. They follow all these weird rules. Like, you can cross a horizontal asymptote, but you cannot cross a vertical asymptote. Same with an oblique one. So, finding the horizontal and oblique asymptotes depends on the degrees of the top. And what the heck is the degree? So, if you remember, the degree is the highest exponent power. Highest exponent power. So we have to look at the highest exponent power on the top, and we have to look at the highest exponent power on the bottom. And in this example down here, they're plugging in x equals 1,000, just saying like, okay, as we're getting bigger and bigger, what is happening to this graph? So like in this first one, we have 3x plus 1 over 4x squared plus 1. So the degree on top is less than the degree on the bottom. Which if we plug in 1,000 here, we end up with 3,001 over, this is about 4 million, which if we divide something pretty small by something big, that's just gonna get closer and closer to 0. So this one has a horizontal asymptote at 0. This next one, so say, well, what if the degree on top is equal to the degree on bottom? Well, if they're equal and we plug numbers in, we end up with about 3,000 over 4,000, which really, that's really close to 3/4. So this one will have a horizontal asymptote at 3/4. Now, what if the degree on top is 1 greater than the degree on bottom? So we have something really, really big on top. Not really big, but decently big. So we have about 30,000 divided by 4,000. On this one, we have to use long division to get that, which I'll go over in just a second, to get this equation here. So long division, and this is when you get your oblique asymptotes. So the oblique asymptote is when the degree on top is 1 greater than the degree on bottom. Now, if it's more than 1 greater, we have like an even bigger number up top here. That's like, what, 30,000 or something? Or 300? That might be 3 billion. That's like how much Jeff Bezos makes. So he actually, is he a trillionaire? He's so rich, dude. Like, what the heck? But so if he has, if there is like 3 billion on top and 4,000 on bottom, the top is obviously bigger than the bottom. There is no asymptote here. Whoops. None. Okay. Let's go through how to find some vertical ones. So the vertical ones, this is when you have 0 in the bottom. Now remember, you cannot divide by 0. Can't divide by 0. Because if you divide by 0, the whole world just blows up, and then we fall into a black hole, and who the heck knows what happens. But we cannot divide by 0, because when we divide by 0, it's like everything collapses into itself, which is like, maybe that's really what happens when there's black holes. I don't know. I'm not an astrophysicist, but it'd be really cool. It's not cool. Like, anyways, but, so to find the vertical asymptotes, it's when, like, what value is going to plug in there to give us a 0 in the denominator. Okay, so this is when you cannot divide by 0. So, like, if we look at this down here, we have x squared minus 3x over 2x minus 2. Well, if I factor that, I get x and x minus 3 and 2 and x minus 1. Well, the 2 is not going to equal 0, but here I can get a 0 at x equals 1, because if I plugged 1 in there, that would be 2 times 1 minus 1, which 1 minus 1 is 0. So we get 0, which means that we would end up dividing by 0, which you can't do. So that's where we get our horizontal asymptote, or our vertical asymptote. Vertical asymptote. Okay, let's go through some examples now that we have talked about that. Okay, so we want to find the asymptotes of each function. The first thing we're going to do is we're going to find the horizontal asymptote. Did you just say I have to look at the coefficients of the horizontal to find the horizontal asymptote? Yes. Write this table down. So horizontal asymptote rules for P of x over Q of x. If the degree of P, so the degree of the top, is less than the degree of Q, you have a horizontal asymptote of y equals 1. If the degree of P equals the degree of Q, you have to divide the leading coefficients to find the horizontal asymptote. If the degree of P is greater than the degree of Q by 1, so it's only 1 greater than, you have to use polynomial long division to find the slant, or slant is the same word for oblique asymptote. Okay. Now, what if the degree of P is greater than the degree of Q by more than 1? Well, then that's the easy one. There is no horizontal or slant asymptote. Please write that table down. I promise it will help you. Okay, so let's look at this. So for this one, the degree of P is 3 from here, and the degree of Q is 2. So that means the degree of the top is 1 greater than the degree of the bottom. So I'm going to use long division to find the slant asymptote, which hopefully you remember, divide first with first. So x cubed divided by 3x squared is x over 3, which is the same as 1/3 x. Multiply it, you get x cubed, 1/3 x, or times 3x squared is x cubed, 1/3 x times 6x is 2x squared. Subtract, change those signs, so negative 2x squared, bring down that 9x, divide again, so negative 2x squared divided by 3x squared is negative 2/3. And then we can stop, okay? Once you are at this point, once you get it in the form of mx plus b, you can stop. We just ignore the remainder. Okay, the remainder ends up being like so minuscule. Like once you start plugging in really, really big numbers, the remainder essentially goes to 0. So then we don't have to worry about it. Okay, so we have an oblique asymptote or a slant asymptote at y equals 1/3 x minus 2/3. Now we need to find our vertical asymptote. And to start finding our vertical asymptote, we are just going to factor everything and get this in lowest terms. So on the top, I can factor out an x. On the bottom, I can factor out a 3x. And then that top x squared minus 9 can factor further. I guess I'm not factoring it further. It can factor further to x minus 3 and x plus 3. But notice here, why didn't I factor it further? That bugs me. This factors further to x minus 3, x plus 3, over 3x and x plus 2. Okay, and then notice here, like Mr. Bear over here is so sad because his friends canceled on him, which I'm trying to get at, that these x's here cancel. So this x cancels this x. When that happens, when you have something cancel on top and bottom, it creates a hole. Okay, we just have this weird hole in our graph that there is no values there. Okay, so we have a hole at x equals 0. Since these x's canceled, it was an x that canceled, then we can say x cannot equal 0, which is where we get, or x equals 0. Because if it was like an x minus 2 that canceled, it would be, the hole would be at 2. Okay, so we have a hole at 0. And then our simplified equation is x minus 3, x plus 3 over 3 times x plus 2. Now we are going to plug in 0 to find the y value of that hole. So that's going to be 0 minus 3 times 0 plus 3 over 3 times 0 plus 2, which that's negative 3 times 3 over 3 times 2, negative 9 over 6, which is negative 3 halves. So we have a hole at 0, negative 3 halves. Now we still haven't found our vertical asymptote. So if we look at our simplified equation here, notice that we have an x plus 2 there. So we have to say, well, x plus 2, we don't want that to equal 0 because that's what's going to give us our vertical asymptote. So set it equal to 0, which means our vertical asymptote is at x equals negative 2. Okay. Now, if we graph this, which we'll get into graphing it next time, I just did this on Doceri, but if you graph it, well, here's our slant asymptote right there. Here's our hole, and here is our vertical asymptote. Okay, let's do another one. So this one right here, we want to first figure out our horizontal asymptote. Well, it looks like the degree on top is 2. The degree on bottom is 2. So we're just going to divide the leading coefficients. So this is going to be y equals the leading coefficient on top. So I'm looking at this right here. The leading coefficient on top is negative 1, and the leading coefficient on bottom is 1. So that's going to be negative 1 over 1, which is negative 1. So we have a horizontal asymptote at y equals negative 1. Then we need to find our vertical asymptotes and our holes, and we're just going to factor everything. So on top, I can factor out a negative. Then the top of that factors to be x plus 4, x minus 2, and the bottom factors to be x plus 2 and x minus 1. So nothing cancels, which means that there is no holes. And then to find our vertical asymptotes, I'm going to set that x plus 2 equal to 0, so x equals negative 2. X minus 1 equals 0, so x equals 1. So we have two vertical asymptotes at negative 2 and 1. So if we graph this, that's what the graph ends up looking like. We have our horizontal asymptote there at negative 1, vertical asymptote at negative 2, and positive 1. Okay, let's do another one. So this one, we want to figure out first our horizontal asymptote. So this one, the degree on top is 2, the degree on bottom is 1. So the degree on top is 1 greater than the degree on bottom. So we have to use long division. We divide this, x squared divided by 2x is x over 2, or 1/2 x. Multiply, you get x squared plus 3x. Subtract, change those signs. Hey, stop it. Because now you'd be left with that negative 4, which negative 4 divided by 2x you end up with. That would just be your main game. So we have a slant asymptote at y equals 1/2 x. Now we're going to find our vertical asymptote by factoring everything. So the top factors to x plus 4, x minus 1. Bottom factors to 2 times x plus 3. So there's no holes. And our vertical asymptote, we're going to set that equal to 0, and you get x equals negative 3. So vertical asymptote is at x equals negative 3. So if we graph that, it looks like this. There's our slant asymptote. We have no holes, and there's our vertical asymptote. And we'll get into actually graphing these next time. Okay? Okay, let's do another. So this one, we want to know what our horizontal asymptote is going to be. So the degree on top is 2. The degree on bottom is also 2. So they're the same. So we're going to divide the leading coefficients. So that's 1 over -4, which is -1/4. So our horizontal asymptote is y equals -1/4. Vertical asymptote, we first need to factor everything and then get it in lowest terms. So we have x plus 4, x minus 3 for the top. I factored out a -4 on bottom, and we have x squared plus x minus 6, which the bottom factors to be x plus 3 and x minus 2. So there's no holes here, nothing cancels. And then that x plus 3 equals 0, we get x equals -3. X minus 2 equals 0, we get x equals +2. So our vertical asymptotes are at -3 and 2. So if we graph this, there's our graph. We have a horizontal asymptote at -1/4, so right there. Vertical asymptote at -3 and +2. Cool? Oh, okay, see ya. Bye, guys. Have a good day.